Can robots develop feelings like humans? No, I'm pretty sure they will never do. Robots are built of mechanical parts, gearboxes, sensors, software and computers, and they are not really living beings. So therefore they will never develop a motivation like biological systems will do. What is the best thing about robotics? Robots are very fascinating interdisciplinary products which can interact with humans. So they touch at the very different disciplines, at all the engineering disciplines, from computer science, AI, up to mechanics and design. And on the other side, they need also social behavior. They need to interact with people. So it's also concerned about social interaction, about ethic questions and so on. This makes robot really probably the ultimate machine in our environment, and it's somewhat a dream for a lot of engineers to build machines which have at least some possible interaction with humans and can reach in some fields our capabilities. What is the most challenging aspect when designing medical robots? The medical environment, especially the operation rooms, are very delicate because they have to be very sterile. So first of all, the robots have to be easy to clean and be adapted for this typical environment. Additionally, these robots have to be used by medical doctors which are not robotic specialists, so they need an easy interface so to work with them. And additionally, these robots have to be very safe. They are used in an environment where each wrong movement can probably meaning the death of a patient. And so the robots have to have very special security measures. How is deep learning used with robots? Robotics is a big user of deep learning. Imagine a robot has to perceive its environment and has to understand what's going on in the environment. So deep learning helps us, based on a lot of data, to learn which are humans in the environment, which are probably objects which the robot has to grab, which are cars, where is the street crossing and so on. In this sense, deep learning has a very strong added value for robotics. Another example is, imagine you have a robot with 4 legs or 2 legs which is starting to learn walking. Walking is not so easy to really define, to model, to really directly pre-program. And so learning can help us in simulation that the robot can learn to walk, the robot can learn to get on his legs again from falling down by going through millions of examples, and each time you optimize more or less the mapping from the situation to the next step of the movement of the legs so that the robot can get back on legs. There was actually recently very nice work which was done at ETH to show that learning can do a great job in this field. What is the future of robotics? I hope that robots will be a very fascinating tool in our daily environment, be it at a job or at home. They will do all the dirty, dull and dangerous jobs which humans probably should not do. In research, the future of robotics is still a long way to go, because robots are still very stupid today. It's very complex to build robots which can match the requirements which we have in our daily environment. In contrast to industrial settings, where robots actually build our cars every day, our daily environment is much more complex, much more diverse, and the robot have to learn to deal with situations which were never programmed before, which are very surprising. This is what humans can very well, but robots today cannot do. But gradually robots will actually appear in our daily environment, will do jobs which we probably won't do, and will fulfill their task in a very good way. How far are we from developing the Iron Man suit? Iron Man suit is a dream since quite a long time, on one side on the science fiction end, and on the other side also in, for example, military. Military has the vision to have Iron Man suits which will make soldiers to superpowers. But this is again something very complex. You have to have highly integrated actuation. You have to have force control, which really allows the human to move as we can do without an external suit. And this is very complex. I think we are just in the beginning there. and it will take a lot of research to really handle all these different elements, which is really from mechanics, control, actuation, up to the interaction with the human. Are robots smarter than humans? Of course they are not. But of course robots can also do in certain fields a much better job than we can. Imagine in the factory of cars, spot welding is a very important issue. Robots can do spot welding at very precise locations, 24 hours a day, 365 days a year. This is much too tiring for humans. We are not so precisely in positioning actually the spot welding tool. So there is fields where the robots can do a much better job, but in a more complex environment where you have to think and reason about very complex situations, humans are still much better. And I think this is what smartness means for us humans. So robots will complement us in a lot of fields. They will do the very dirty and dangerous jobs and hopefully give us a better life at home, but also in our daily work environment. Is robotics a discipline of engineering? Of course, robotics touches at all the engineering disciplines. So the mechanical body is mechanical engineering. You have sensors, cameras and so on, which are more in the field of electrical engineering. And you have, of course, a lot of software intelligence, which is more of the field of computer science. So, for example, in my research lab here at ETH, we have a big mixture of different people, come from different fields, but each of them are actually also touching other fields. So computer scientists are learning about modeling of mechanical robot behavior, and mechanical engineers start to learn programming the robot. And additionally, of course, we will from time to time also have people which are more in social science, for example, which will help us to develop robots which can easily interact with humans. What is the smallest size a robot can be? Actually, probably the smallest robots in the world are actually directly here at ETH. My colleague Brett Nelson, professor for small micro robots, develops robots which are of the size of less than a millimeter. These robots eventually in the near future will move in our body, will probably bring medicine to specific places in the body, and there be a very helpful tool in medical robotics. Of course, these small robots are not fully autonomous with all things on board. In this small size you cannot pack in sensors, computers and all the mechanical parts. So typically these robots are extremely small, but all the machinery which is used and needed to move the robot around is huge. So for example, huge magnets, which is outside the human body, which actually will control these small devices in the body, or some imaging technology which allows us to see where the robot is currently and to steer it to the appropriate place. How does voice recognition work? I'm personally not an expert in voice recognition, but the concept is pretty similar to other sensing devices, for example cameras. So you have an input in the voice, you have a sound wave which is then transformed to a receiver, microphone, to an electrical signal and then digitalized. So you have a digital signal as an input, and then you have to match this with a certain character. You can imagine, depending on who is speaking and what language you're using, this sounds quite different. So there is a lot of learning in this whole process involved. So you try to match a characteristic noise signal to a certain character. And you can probably have seen this experience yourself in a lot of devices. First you have to train your voice recognition system to your own voice, and it's getting better and better every day. Can humans be replaced by human robots? I don't know what will be in 100 years, nobody can predict, but I'm extremely convinced that in the next decades robots will never match the capabilities of us humans. We are very diverse. We can actually perceive and understand situations and environments. We can interact in a tactile manner with our environment. This is very difficult, and the progress in this field is very slow. However, robots will hopefully soon replace us in some environments where humans should not be. Robots hopefully will replace us in all the dirty, dull and dangerous jobs. Imagine you are far beyond Earth's ground at 200 meters in a mine. There today humans are working in a very unhealthy environment. It's very hot up to 50 and plus degrees. It's very humid, it's a lot of dust, and it's also very bad air. So there, hopefully in the near future, we can replace all the human workers which are down there by robots. Robots which are actually much better equipped for this. Imagine another field. We have a still growing population on Earth. We need to feed these people. For feeding this, we need to be more efficient and more sustainable on the field. I'm convinced that robots will help us more and more to really regularly survey the field, interfere in the field, bring out, for example, pesticides in a very small doses and not spray just over the whole field. So in this sense, robots will hopefully be our partners in a lot of jobs, will take over bad jobs which humans should not do, and will give us a better life on Earth.